let's do this. So really delighted to be here and just be able to talk to so many bright practitioners and engineers that share the same passion for building on cloud. And today I'm going to be talking about something that I've got a lot of scars from in the past. A lot of real time in the trenches and a lot of lessons learned. And that's networking. So when I started doing networking, it was in data centers, physically connecting cables. I couldn't sit behind my workstation and just spin up some servers and networking and have everything just work. It was a lot harder than that. So my name is William Collins. I work for a startup called Alkira. We build network software atop AWS. Also a community builder, and I just love building on cloud. So let's get going. So the first thing I want to look at is, how did we get here? So if my car insurance gets more expensive and I'm paying more for it, I want to know why. Why did this happen? So I want to look at some of the, why do we need segmentation? Why did AWS come out with Transit Gateway? Why is it even important? What problems does it solve? So get into the use case a little bit. And then what are the benefits of segmentation? So it's got to solve some problems. What are those problems and how we're going to fix them in a demo I'm actually going to do later. And thinking through the workflow. So the last dev session about chaos engineering was really awesome. And there was a really important slide in there that said, hey, we're going to do these things in a dev and a test environment first. We're really going to learn from those environments, and they're going to be completely isolated. We're not going to have any customer data or any production-facing things in those environments. So if we mess up, there's a cascading impact. So we're going to look at thinking through the workflow. What exactly we're going to do. We want to plan it out. And then last, I'm kind of kicking myself right now, but I thought, hey, I want to live life on the edge and do a live demo. Let's, Leroy Jenkins this. So I'm just going to jump in and do a demo. So a little about just kind of where I came from, because I think our experiences, or my experiences in IT, sort of inform the way that I view things. So I've worked for a lot of big enterprises ranging in between 15,000 and 8,000 employees with somewhere in between 100 and 2,000 applications. So lots of stuff. And these applications, for a really long time in the real world, we built data centers. Customers owned, managed, did all the life cycle management, all the hardware procurement, all the management of this infrastructure before AWS is around. So a lot of the companies I worked for, they had built these application portfolios. All the things that made them money were living in their own data centers. And then somewhere along the way, AWS came around and sort of disrupted the way we do things. Beyond that, instead of resetting the table, just flip over the table. We're going to do it completely different. So not only is it different with the technology, we use and consume the technology differently, but we have a lot of different, say you're a big organization and you have multiple lines of business. And within those lines of business, you've got multiple departments. This means you have a lot of different AWS accounts. With those AWS accounts, you have a lot of different VPCs. And so as you begin migrating and doing this digital transformation or modernization, whatever you want to call it, and you start transitioning to cloud, you begin to run into scaling challenges. And the scaling challenges that I'm most familiar with are on the networking side. And this is where Transit Gateway really comes into play. So I remember the first time I used AWS and we set up connectivity, it was just a VPN. And then more VPNs started getting stood up because you had more different, more accounts, more VPCs, and then you had to solve for reliability. So VPNs, with the site-to-site VPN, you have like an active and a standby scenario, and then you run into throughput challenges, and then as you scale and you're an enterprise, you go beyond one region, you need DR capabilities, and all these things start to snowball at once, then you're looking for a solution, and AWS answered with Transit Gateway. So to talk about the benefits of segmentation, one of the biggest ones, if you're talking to security engineering or anybody on the security side, they want to minimize that attack surface. They want to make it to where, hey, if something gets exploited, you can't just laterally move. Like say I have a VPC that was set up when my cloud journey first started. And say there's maybe an instance, there's a public IP and you can get in from the internet and it wasn't secured right. There's also some metadata on that instance and they're able to move laterally, and say they can move laterally through accounts and then back to the data center. These things, again, they snowball very quickly. So shrinking that attack surface, which with segmentation means taking a large network and just breaking it down into smaller networks. Environment isolation. Again, with the example of the last dev chat that we had, environment isolation, test, stage, prod. You never want to just test things in prod for the first time. You want to use separate environments. Well, that goes through a lot of different layers with your cloud environment, and networking is one of them. So if you're testing something and you have a lot of stuff that exists in a VPC, and that same VPC has, say that you're just using subnets as a form of isolation, and you do something that has a blast radius that impacts everything. You don't want to do that. You actually want to segment these VPCs. And one example of this, when I worked in healthcare, was our prod environment, we had protected data or classified data, PHI. That only lived in prod. That was never in any other dev stage, any other environment. So taking data is like our classification mechanism from the top down. We could say, hey, these networks are prod. We know that these contain, protected data, and that these dev and stage environments do not. So we can kind of peel those off, and then that helps with the compliance enforcement aspect of it as well. So healthcare regulation, the more ways that you can top-down look and say, okay, these are the environments that have protected data, these are the ones that don't, it's helpful to you. And last is optimizing performance. So if you set up a network and you just say, oh, I just want everything to talk to everything, that's not very efficient. So we're going to look at how we can use Transit Gateway to actually take and optimize the performance behind our networking and our segments. So thinking through the workflow, I already sort of talked about, with account sprawl, you have VPC sprawl. So, I remember one environment I worked in, when we started going through this digital transformation thing, we started out with I was 2 or 3 AWS accounts, and before we knew it, we had 40 or 50. And barely any time had passed, it seemed like. We had a lot of lines of business that wanted to get in on the cloud, just all the synergy around cloud and modernization. So lots of VPCs. And then you run into the challenge of, okay, these VPCs, they've got to talk back to on-premises. You have data centers that you have to interconnect. This is a challenge, and then you have transitive routing stuff in the cloud. So, natively, if you use VNet peering and you have 3 VPCs, A, B, and C, you can't connect VPC A to VPC C through VPC B. There's no traffic forwarding mechanism there that routes your traffic, which is again why we have something like Transit Gateway. So one of the good things that Transit Gateway does as well is it treats, all the things that you want to connect, it treats them in sort of the same way. So I want to attach VPCs. I have a VPC attachment. I have a VPN attachment. I have these different attachment types, and Transit Gateway operates as this sort of this regional router, this regional hub that does a lot of things that network engineers would be used to doing, like in the data center side, really. But it actually abstracts a lot of it as well, so you don't have to dig in, get into the weeds, and do some of the availability and DR focused things manually, like we had to do in the data center days. And so again, I'm gonna do a live demo. I don't know why, but I'm gonna use Terraform. Terraform has sort of become the de facto infrastructure as code tool. I see it everywhere, and that's because lots of environments, they're going to be interacting with things outside of AWS. They may have some ServiceNow or different tools out there, and Terraform has a pretty good ecosystem, a lot of providers, and makes that infrastructure management piece of all this a little easier. So, kind of going into thinking through the workflow, if I'm using Terraform, the default behavior here, if I create a VPC attachment and I attach this VPC to the Transit Gateway, it's going to have a default route table, and it's also going to enable route propagation by default. So if I don't set any parameters in there, it's going to do this by default, which is awesome. It's easy. It's really nice. Not very complicated, but the thing you would run into is if you connect all the VPCs this way, is all of them are going to be able to talk to all of them. They're all going to use that same default route table, and this just isn't good. Back to my example about healthcare and protected data only living in prod. Well, we don't want dev and stage to be able to route to prod. Obviously, we want those separated. And we want a defense in-depth approach to this. So, and that includes identity and access management. It includes the network. It includes all the different pieces of your infrastructure on the security end. So what we're going to go ahead and do is I'm going to create a few different route tables on the Transit Gateway with Terraform that are going to match these VPCs that I have. And then we're going to do the route propagation in a way that makes sense. And the way that is going to look, so first things first, I want to say, hey, like I have a shared services VPC, and let's just say for the sake of demonstration, this needs to talk to everything. So it has maybe like a few security solutions in there that need to reach each VPC. Dev and stage. Let's say that they can talk, back to the healthcare example, we oftentimes would use synthetic data in non-prod environments because you still need to understand the data, you still need to do things around that data. You just don't want to use actual patient data, obviously, so synthetic data. So let's say that dev and stage, they can talk to each other, but prod is going to be on its own little island. Dev and stage should not be able to talk to prod, ever. So now I'm going to switch over. I'm going to zoom in a little bit so we can see this a little better. Might be too big. So I've already deployed a little of this, and I'm going to go through that just so we have an understanding of what I've already done. So this local variables block up here, I've simply defined an object. It's got 4 VPCs in there. I have 4 different CIDR blocks. 1, 2, 3, 4. Can't get easier than that. So from there, I'm just using this simple resource block right here to loop through those objects and create those VPCs. Pretty simple. And then for each one of those VPCs, I have created a single subnet and a single availability zone. And I've already also created the Transit Gateway, because sometimes that could take a while. It takes probably the longest out of each one of these resources. So this is already created. And back to that point of if I remove these two things right here, this default route table association and propagation, everything's going to be able to talk to everything. And again, we don't want that. So we're disabling both of these things. And for each one of those VPCs, I've already created the VPC attachment. So these VPCs have been attached to that transit gateway that we created. And also, I created an instance in each one of those subnets. So here is the config that I haven't run yet, and this is going to do a lot of cool stuff. Let me uncomment this. Save this. What I'm going to go ahead and do is run this, because it may take a second. My internet service has been good, a little spotty at times, so I want to make sure I give it enough time to run. And I also wanted to explain, so I have those VPCs up. Let me make this a little bit bigger right here. So what I've done here, I'm going to grab a code window, iTerm. So from my machine right here, when I created those EC2 instances, they returned my private IPs and my public IPs of each one of these instances. So if I look at this SSH config file, I have an SSH key, and I've got these public IPs. That way, I can connect to these instances and test from right here. Now, when I instantiated each one of these instances, so let's go to the dev instance. So I went ahead and added hosts file. So that way, when I try to reach another instance in another VPC, I'm saying like, ping stage instead of pinging the IP address. And that makes me not confused, and it also makes it easier for you, that are watching. So host files with each one of these VPCs has been updated. So I'm going to go ahead and apply this configuration. And as this is going, I'm going to explain what exactly it's doing here. So the first thing that we have to worry about is so each VPC has to be able to route to the other VPCs. So I'm creating a route for this quad 08 is my destination, and I'm using the next hop is that transit gateway ID that I've already created. So from the VPC side, now these have the route to route to the other VPCs. So now I'm going to create what it's creating right now, a transit gateway route table. Those TGW route tables we talked about, I'm creating one for each VPC, the dev, stage, prod, and shared. And then each one of these route tables right here, they're going to have a one-to-one mapping to the attachments we created. So that is called an association. So I'm just referencing the attachment ID of each one of those VPC attachments along with the route table. And then this is where where the route propagation happens. So Terraform has a resource called route table propagation. And I name these in the fashion that I want them to talk. So prod to shared, shared to dev, shared to stage, and shared to prod. So these are all the different, route propagation blocks that we have that tell us, by default, since I disabled the propagation, nothing can talk to nothing. So these set up that access for me. So let's go ahead and see if this is done running. So it's done running, and I'm going to go ahead and do a little testing. So I'm going to connect to the dev instance, and this should be able to reach stage now. Okay, that's good. And it should be able to reach shared. Okay. And prod should not be able to reach prod. So we've got that isolation in place now. Those are separated. Now, I'm not going to log into stage because it's, working really similar to dev. So let's go into shared. And shared, this is a shared services VPC. It should just be able to talk to everything. So it can talk to dev. It can talk to stage, and it should be able to talk to prod as well. All right. So last one is prod. And prod should only be able to talk to shared. So we can see that it can reach shared and shouldn't be able to reach dev, and it can't. It shouldn't be able to reach stage, and it cannot. So we have this segmentation in place now. If you're curious about actually looking through this infrastructure as code and how it was put together and how everything's sort of interconnected, I went ahead and threw this up on a GitHub as well, which I should have a link for here. I think at the end. So this is the last slide. I didn't put my GitHub link in there. So if you do want to see the actual infrastructure as code, my GitHub handle is wcollins. Pretty easy to remember. And there's a repo called DC Summit. So that's it. That's all I have.